Hello, everyone. My name is Michael Katchinskiy, and I'm a security researcher at Aqua. I'm also a computer science student at the Technion in Haifa. And at my work at Aqua, I focus on researching and analyzing new attack vectors on cloud-native environments.
Hi, and my name is Assaf Morag. I'm very excited to be here. I lead the threat intelligence and data analysis with Aqua Nautilus. So Aqua is a CNAPP company. We aim to protect all the workloads and environments of cloud native, starting from code through CI/CD, registries, and workloads. And Aqua Nautilus is the research team in Aqua, and we want to learn about the attacks, the attackers, what they're doing, how they're doing it, what they're doing after they get in. And we are doing it in order to understand how we can write detections and how we can help our customers and the community to protect against these kinds of attacks. Today, we are going to talk with you about research that we've been conducting over the past 3 months. And obviously, it revolves around Kubernetes. We are going to start with exploring the Kubernetes attack surface. And then we're going to talk about how one single YAML can lead to catastrophic results. Then we are going to show you some use cases from the wild of companies that we've seen that were completely exposed. And we are also going to show you some use cases of attacks from our environment of honeypots. Then we're going to play a little bit of a game to detect the malware in a running Kubernetes cluster. It's going to be fun. And we're going to show you some ways to detect and mitigate these kinds of events. Okay, why Kubernetes? We are in a Kubernetes conference, and in 2023, you can't be a CEO without knowing what is Kubernetes. But you obviously already know that. You also know the value of Kubernetes. You can see here that the commits and the work on Kubernetes has been increasing over the years, also the usage. And it's basically has become a gold standard. And the CSPs, the providers such as AWS and Azure, they actually reduce the level of complexity, and it could be as easy as to push a button to create a cluster, so even Michael can do it. But it's not only the practitioners who notice Kubernetes, also attackers. So large botnets such as Katchinskiy and others, they target Kubernetes as a whole. They're trying to look for Kubernetes clusters in the wild and to attack them. But it's not just Kubernetes as a whole, also the components, because they're getting very proficient and they're getting very good at it. So kubelet, misconfigured kubelets, etcd, API server, they are all in the game, they are all being targeted.
Okay, let's talk a little bit about Kubernetes attack vectors. Okay, so this is a typical Kubernetes cluster. It consists of a control plane and 2 nodes. You can see on the control plane there's the API server, the etcd, the scheduler, and the controller. And on the nodes there are the kubelet, the proxy, and your other application. Each of these components could possess some risk to your cluster when doing something wrong. From public-facing applications with known CVEs and exploit, to misconfigured applications such as Kubernetes dashboard, for instance, misconfigured kubelet, and even misconfigured API servers. We've heard it all for the past few years, and there are countless of attack vectors into a Kubernetes cluster. On our research, we chose to focus on the API server as the attack surface. The API server is the primary entry point to the cluster. It has full control over the cluster, and it is frequently located outside of the VPC, which means that everyone with practically internet connectivity would be able to connect to it. It also governs the RBAC secrets. And lastly, we must remember that Kubernetes is just one part of the software development lifecycle. So on a standard cluster, you might gonna have some integrations to third-party applications. For instance, you're going to have a MongoDB, and this MongoDB is outside of your cluster, and you will need to interact with it somehow. You will need to save the credentials of this MongoDB somewhere on your cluster. Moreover, you might have a Docker registry that you need to pull and push images from. Those credentials to the Docker registry will be also saved somewhere on the cluster. And it's important to note that we've seen lots of attacks on Kubernetes clusters. In most of them, when an attacker gained foothold into the cluster, they usually try to access the API server. So for attackers and for us researchers, gaining access to the API server with high privileges is like getting the keys to the kingdom. Okay. So we decided to name our talk One YAML Away from Disaster. This is because two main misconfigurations that we kept seeing, and both of them possess immediate threat to clusters. They are not new. We have seen them for a long time, but we wanted to figure out why they keep showing up, and we wanted to see what's the impact that they still cause on organizations. Let's deep dive into the first misconfiguration. As you can see on the screen, this is the zero-click default configuration of an EKS. As you can see, the API server will be located outside of the VPC, which, as I said earlier, it means that everyone with practically internet connectivity would be able to reach it. And on the bottom of the screen, you can see a simple showdown search. On this query, we found that there are over 1.1 million Kubernetes clusters that are accessible from the internet. Moreover, there's a very nice flag called anonymous auth or anonymous authentication. This flag is enabled to true on Kubernetes native, and it practically means that everyone which wants to connect to your cluster and choose to do it without a specific authentication method will be automatically assigned to a user, and this user is called system anonymous. As you can see also, this flag is enabled on EKS as well. It doesn't mean that the system anonymous user will have any permissions, but we would be able to get assigned to it. So let's go over the process of interacting with your cluster. DevOps and developers try to access the cluster. They go through the etcd, and if network controls allows it, they go through a phase of authentication, and then through a phase of authorization. When doing the same thing with the anonymous user, things get a little bit different. We try to reach the API server, and then we go only through a phase of authorization. The authentication phase is completely redundant. So to sum it up, we saw that we might going to have connectivity to the API server because of the default configuration, and we will have a user, and this user is the system anonymous user. The system anonymous user, or the configuration, is a known problem, and since 2019, people started complaining about EKS to change this configuration, and even 2 years later, and even until today, nothing has been done to do it. So to sum it up, the default configuration makes us one step away from disaster. Giving anonymous user any permissions will practically mean that we are giving permissions to the whole world. And as you can imagine, we've seen clusters that gave the anonymous user some permissions. This is an example from a cluster that gave the anonymous user cluster admin permissions. Okay, let's deep dive into the second misconfiguration. We have already seen this slide. And there's a very nice feature on kubectl called kubectl proxy. It is a proxy, and it runs on your workstation. The proxy will start listening on port 8001 by default, and it will accept requests from the localhost network interface. It is commonly used for convenience and even to access internal applications that are not exposed outside of the cluster. Combined with those flags, with the address equals 000, it means that now the proxy on the workstation will listen on all network interface, not just the local host. And when combined with the accept host flag, it will accept requests from all of the reachable hosts. So for example, you have a developer in your company. And this developer is working on a large private network, or even on an EC2 with an exposed IP address, with an external IP address. Everyone that could reach your developer's workstation would be automatically forwarded on port 8001 by default, as I said, to the API server. So you might think to yourself, this is not that horrible, because we saw already that there are around 1.1 million Kubernetes clusters that could be accessed from the outside. But this is not the case. This is a real security risk, because if someone would be able to access your developer's workstation, they will automatically gain the permissions of your developer. So if your developer is a cluster admin, for instance, they will be cluster admins as well. It is also quite problematic to control, because you can't control everything that your developers are doing on their workstation. It's not like writing OPA policies or something on your cluster. It is mainly happens on the workload, on the workstation. And there are even blogs that explains about it and explain how to run this command. And they tell you how to deploy the Kubernetes dashboard to make it available. But they don't understand that they're exposing their whole cluster. So let's talk a little bit about the findings and use cases and what we found out there in the wild. We've started with around 1.1 million Kubernetes clusters, as I said earlier. And we've ended with around 350 impacted companies. Some of them companies were small, some were medium, and some were large, Fortune 500 large. They came from various sectors: financial, aerospace, car manufacturers, industrial, security, and more. And the cluster size ranged between 1 and 30 nodes. The clusters were from all around the world, from America to Europe to Southeast Asia. And we've seen clusters from all of the cloud providers. We've seen Amazon, we've seen Google, we've seen Microsoft, we've seen Alibaba Cloud, and we've seen Yandex. In most cases, we were able to query the config maps and secrets. But on some we did not. We had just the permissions, for instance, to list the pods. And this is an example of a real cluster that we were able just to list the pods. We found a nice pod. Its environment variables contain information about the AWS access keys, the MongoDB, the Google, the Facebook, the Redis, the Twilio, and a verification email. Do you remember that I talked with you a few minutes ago about integration to third-party application? So this is the case. And just to emphasize, it's not just closing the door and fixing the misconfiguration and making sure that everything is fine. You're going to need to check all your third-party applications, and you're going to check there are no backdoors and nothing has been left or no one has breached. Another cool use cases that we've used is using the built-in proxy of the Kubernetes API server. It's not the kubectl proxy, it's a built-in proxy, and it's located on the API server. This proxy enabled us to access internal applications. Those applications were not exposed, or they were exposed, but they were behind the firewall. We were able to proxy ourselves from the API server into those inside applications. Some of these applications did not have any security measures because they're internal. But on some, we did need to enter user and credential. But to be honest, we found the users and credentials somewhere on the secrets, and we were able to get access to the harbor, as you've seen before, to the Elasticsearch, more databases, and more applications, which was quite fun. Now, let's take a look on a cluster that we've seen out there. This cluster is a Minikube, just one node, and as you know, Minikube is mainly used for testing on local environments. This Minikube had a MySQL, Kubernetes dashboard, and MongoDB. But on those secrets of this Minikube, we found credentials to the MongoDB, the GitLab, and the Yandex Cloud. This MongoDB and the GitLab and the Yandex Cloud belong to production systems, not the MongoDB. And we practically got the databases, the source code, the credentials to the Yandex Cloud, and we had access to the whole software development lifecycle, which was compromised. Now I'll hand it over to Assaf, and he will continue.
Michael didn't convince me. I think it's off. Yeah. Okay. Can you hear me? Yeah. So Michael didn't convince me. It's just a Minikube. Who cares about a Minikube? But this is a little bit different. We also found some bigger clusters, like this one. This is 21 clusters exposed to the internet. And the admin here, the Kubernetes admin, ran the kubectl proxy command not on one, on 5 EC2 endpoints, servers. And all these 5 EC2 machines were exposed to the world. So one of them had an admin privileges. So through that, you can tunnel, exactly as Michael said, to the cluster, to the API server, and get an admin access to the entire cluster. And just think about it. Just think about it. MySQL, the Airflow for the machine learning, the SSO, the single sign-on of the company was in there. AWS credentials to the console, to S3, Helm, and so on and so on. So the remediation of such a disaster is to close the company. No, I'm kidding. But just think about it. You need to, you really need to stop the cluster. You need to rotate everything there. You need to rotate the keys. Think about how many days you're losing there. So we wanted to show you some examples, not only of companies that we've seen, and we've seen a lot of companies. We spoke with a lot of companies. We spoke with a lot of mortified practitioners and engineers, but we also wanted to share with you some intelligence, some information from our honeypots. And as the research team, we build honeypots. We build the honeypots in order to understand what the attackers are doing once they're getting in. Because with honeypots, what you do is you create an application or an environment, you introduce misconfiguration or vulnerability. Most of the times they get in, the attackers, through that. Sometimes they surprise you and then you learn about new vulnerabilities or misconfigurations. And in this case, we have many honeypots such as Redis and MongoDB and so on. But in this case, we created a honeypot of Kubernetes. We exposed the API server to the world with an admin privileges, so everyone can get in, and we hid some surprises there, such as canary tokens, secrets. I'm going to explain about it in a few moments. And Tracy. Tracy is Aqua open source. I'm going to explain about Tracy later too, but it basically records in the kernel level events and allow us to learn and to understand about what the attackers are doing. Okay, so first I'm going to speak about the SSWW campaign, and I'm going to explain what is the SSWW campaign in a few moments. The first thing the attackers are doing when they get into the environment is to understand further about the environment. It's only natural. Just they're listing the nodes and they're seeing which nodes are there. Very simple. Next, they are deleting competitive campaigns. So think about it. You have some, you have an exposed environment. Maybe some other attackers have already exploited it. So they're trying to remove the noise, reduce the noise, and to reduce the CPU consumption, because most of the campaigns that we see there are of crypto mining. In this case, we didn't have it, so they got a 404. Next, they are deploying their own daemon set. And when deploying this daemon set, they are actually running a pod of, with crypto miner on each of the nodes. And let's dive a little bit deeper to what they are running there. So as you can see in the commands, they are mounting the file system, the root file system, and gaining access to the host. Every one of the hosts, because it's a daemon set, and they are running a cron job with SSW. They are doing in the middle. You can see that they are doing curl, downloading SSW from the C2, their server, which is basically what we call a secondary payload. But they can run, now that they have access to each and every one of the nodes, they gain strong persistence and they can run there basically whatever they want. In this case, they ran some crypto miners and rootkits, but they can do whatever they want. So just to sum up, it's the SSWW campaign it's a very strong campaign because they gain strong persistence. Another campaign is the RBAC Buster. We wrote a blog about it, so you can read a little bit further than what we are showing here on our website. But the RBAC Buster, basically, the first thing that the attackers are doing is to create a cluster role, and it's basically an admin cluster role. This cluster role is with the name controller, kube controller, and it's a pretty standard name, so we shouldn't suspect that something is wrong with such a cluster role. Then they're doing a cluster role binding to another standard service account. And again, nothing that should raise any suspicion here because it's all looks legitimate and very standard. Then they are listing the secrets. By doing that, they collect the token. And now that they have the token with a role, an admin role that they just created, they can gain access if we close the vulnerability or misconfiguration or the first initial access that they gained, because it's irrelevant now. They have an access to the cluster. Next, they listed the config maps because we hid there, and this is something I talked about earlier, they hid their canary token. The canary token is not an ordinary AWS or any other secret. It basically beacons back to us. So now, whenever someone is using it, we know that they used it. And in this specific case, they were trying to see what this AWS key can do. So they're not just listing the secrets, they're also using them. Next, they ran a daemon set. And again, the daemon set runs on each and every available node. And in this case, they're using the kube controller, again, the same name. And they're running from Kubernetes IO a kube controller. It seems very innocent, but if you have noticed, it's not Kubernetes IO, it's Kubernetes IO, and it's a type of squatting. It's a technique attackers are using. Downloading from Docker Hub crypto miners. But again, they can download whatever they want. Now they have strong possession of the cluster. Okay, so let's sum up everything that we spoke about. Attackers are massively scanning for misconfigurations and vulnerabilities. They hide backdoors. So even after we close the initial access, and sometimes we've noticed that in the large organizations, it took them between 3 hours and few days to discover the misconfiguration. So they understood that something is wrong and closed it. In some other companies, smaller ones, it took a little bit longer. They are masquerading the malware and the malicious tools that they are using, and they are scanning for secrets and using them. So I think you're ready, and we can play a little game together. So we listed, this is an actual organization that was attacked in the wild. We listed the pods. Anyone can find the malicious pod. Michael, lower your hand, please. Okay, let me help you. I just wanted to make a point that it's difficult, and you are missing some information and the ability to query the cluster. But if you run the logs of this specific pod, you can see that it is trying to communicate with support XMR. Support XMR, if you are a crypto miners enthusiastic or security enthusiastic, you know that support XMR is a crypto mining pool, and this innocent looking pod actually is running malicious content. So that's it. Let me challenge you a little bit further. So this is a more realistic cluster, and I assure you, and it's not just there are two screens, and I assure you that there is a malicious pod, it's list one running here. So just to help you with that, again, this is the kube controller. This is actually the example of the RBAC of the RBAC buster. And if you had this kind of crypto miner or this kind of malicious tool running in your cluster, whether if it's with this tool or any visualization or orchestration tool, it will be extremely difficult to understand what's running there and that there is a malicious content. So let's get a little bit serious and talk about how you can detect and what you need to do in order to mitigate. So one open source tool by Aqua Security is Aqua Hunter. It's a great tool for pen tester and red teams designed to scan from the outside, and you can get some great information such as exposed APIs, services, secrets, and so on. You can download it from Aqua Security, or you can run it from Docker Hub, from GitHub, Aqua Security GitHub. And once you run it, you will get information about your nodes, your API server, and you are also going to get information if you have any exposure, such as your API server is listening to the outside to anyone, to an authenticated user, or anyone can list roles, secrets, and so on. Another great tool, open source tool by Aqua Security is Aqua Trivi. I don't know if you, I'm sure that some of you or all of you have heard of it or used it. It's an all-in-one security scanner. You can scan your environments, you can scan Git repositories, container images, file system, and even Kubernetes. And you can gain a lot of information such as the SBOM, vulnerabilities, misconfigurations, licenses, and so on. And another open source tool by Aqua Security, Aqua Tracy. And this is what we use in our honeypots environments. It's a runtime security and forensics utilizing eBPF technology. We capture events in the kernel level, and it comes with built-in security policy or security rules, which allows you to detect malicious activities such as malware, rootkit, malicious network events, and so on. We also highly recommend to use some admission controls, such as this one that we've found in Artifact Hub. It will disallow the association between cluster role and anonymous users, and will help you strengthen your environments. And to sum up, you can scan from the outside with Trivi and Hunter. You can scan your control plane, and on the other side, the nodes, the workloads, the containers, and you can install Tracy on your nodes and use Artifact Hub policy admission controls to harden your control plane. Okay, just to sum up the mitigation. We at Aqua Security believe in defense in depth, which means that the security should be handled in layers. And I think that right now we are doing the first layer of education, just to learn about what attackers are doing, the implications of these misconfigurations, and there are many more layers of education that you can absorb. We strongly advise to use compliance and control policies in your environments, limit the traffic. We've seen that there are lots of exposed API servers there. You should really limit the traffic to the API servers and any other significant environments. Use admission controls, scan your clusters, and monitor your workloads. We wish to thank you and enjoy the rest of the day.
Thank you.